Hello, everybody, and welcome to our trigonometry review. We're going to continue section 8C from your textbook and 8D. So first, a little reminder about the unit circle. Remember, on the unit circle, we're taking our trigonometry from triangles to circles, and we're going to start by sweeping our initial arm up from the x-axis to some point. Now, this point has coordinates cosine theta, sine theta. And why does it have those coordinates? Because if theta is our angle, then to get to, and our radius is 1 because it's a unit circle, the x coordinate for this point is cosine of theta. Remember that cosine theta here is x over 1, okay? Whatever our x distance is, our adjacent over 1 for the hypotenuse. So therefore we can say that x is equal to cosine theta, and the y, or the vertical height of this point, is given by sine theta. Again, because our radius is 1, sine theta is the length of the opposite side, which is however big y is, over 1, and if we rearrange, we'll see that y is equal to sine theta. And notice that as we rotate this through the unit circle, the values for sine and cosine and tangent do change. So in this quadrant, sine, cosine, and tangent are all positive. In this quadrant, because sine is opposite over hypotenuse, it is still positive, but cosine is adjacent over hypotenuse, and that is a negative value, so our cosine will be negative in this case. And our tangent has to deal with opposite over adjacent, so it'll also be negative. Okay, that's a little bit of cast rule. Okay, in this quadrant, only sine is positive. Sorry, in this quadrant, only sine is positive, so all soup turns cold. In this quadrant, only tan is positive, and in this quadrant, only cosine is positive. All right. Also, we want to talk a little bit about the unit circle. So how do we use it? Well, we need to know our special triangles off by heart. They will help us do a lot of trigonometry in our head. And notice I've drawn them here with radians instead of degrees. Generally speaking, we'll use radians unless told not to. Okay, so if I want to find a value of a trig ratio and I'm given some information, then I have a few steps I need to follow. First, I'm told sine theta is 2 over 5, so I know that the opposite side is 2 and the hypotenuse is 5, or in our circular definition, y over r is our expression, so we know the y and we know the r. Okay, because this is telling me that this is between 90 degrees and 180 degrees, I know that my terminal arm has rotated into this quadrant. If I want to write the cosine ratio, then I need to know the x value. So I find the x value by using the Pythagorean theorem here. X squared plus y squared equals r squared. I rearrange it, plug in the values I have for y and r, and find out that x must be equal to, in length to root 21, but negative because it is in quadrant two, this quadrant over here, quadrant 2. Okay, so then we can write cosine as root 21, which is negative over 5. And if we want to solve for theta, we could by taking cosine inverse. In this case, we'd have to use our calculator to help us.